Okay, so this is 1C, which is practicing all the different parts of the graph. So, practice number 1, we have a cube root function, and it's increasing intervals. As you're going along the graph, so taking from left to right, as you're going along, at all points, increasing is like, it's the same thing as a positive slope. At all points, it's a positive slope. So all the way along this graph there's a positive slope. Always assume these graphs also are continuous. So increasing intervals, in this case, it's increasing from negative infinity. Always talking the x values, increasing all the way to infinity. Decreasing, since the whole portion of the graph is increasing, there's no decreasing portion of the graph. So none. You can also think of decreasing as a negative slope and increasing interval as a positive slope. Domain is the are the x values. So the x values, as they keep coming from the left, they're coming from bigger negative numbers, the x values, and then they continue on and on and on. Like the x value here is at 6, keeps going to the right, 8, but keep on going to infinity. So the domain is negative infinity to infinity. You can also write this as all real numbers. So there's 2 spines on the back of the arm. Range is the lowest y values to the highest y values. So range is, as this is going further and further down, or left, it's going to keep on going down. So it's coming from negative infinity on the range, and it keeps on going up, 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 forever and ever. Range is the y values, right? Range is the lowest to the highest y values. That's negative infinity to infinity. Zeros is where it's across the x-axis. At 2, 0 is a number. Zeros are a number. The x-intercepts are actual coordinates, 2, 0. The y-intercept is it's a coordinate. It's at 0, negative 1. The domain restrictions. Domain restrictions mean is the graph, does it have a break in it somewhere? In this case, it's continuous. If it's continuous, there's no, like, if you could draw the whole graph with all left in your pen or pencil, then it has no domain restrictions. If you draw your graph and you have to lift your pen or pencil to draw the graph, then it has a domain restriction. End behavior. I always start out end behavior with the left side of the graph. So as x goes to negative infinity, think of this as the left side of the graph. The y values of x go to, where does this go? So as x goes to negative infinity, so I'm looking strictly at as x goes to negative infinity, so that's over here. And I look at the end of the graph. What's happening to the end of the graph? It is going down as it's going left. So down, the y values are negative y values, so it's going to negative infinity. And then we can talk about the other side. As x goes to positive infinity, the y values go to, let's look at the graph. So I have the right side of the graph. So I'm looking at here and over here. Right side of the graph. As I'm getting positive, bigger and bigger x values, the graph is also going up. It's going up to positive infinity. Moving on, we have a rational function. 2 parts of the graph here, so we know that there's going to be some domain restrictions. First, let's talk about increasing and decreasing. So, increasing is a positive slope. So if I'm following this graph, that looks to be a negative slope. That's decreasing. Decreasing, and if I follow this graph, left to right, and it is also decreasing. I don't have any portions of the graph that are increasing, so we say none. Decreasing intervals, that we have two different parts. So this graph decreases, and we're always talking x values. It's coming from the left, which is negative infinity, and it's decreasing to, and there's an asymptote that runs through here. Vertical asymptote at x equals negative 3. So we're going to say it's decreasing from negative infinity, the x value, to negative 3. And there's also another portion of this graph that decreases. It starts at negative 3. This is getting closer and closer to negative 3. So it's going to be negative 3, x, and it's going to continue on. The x values are going to continually get bigger and bigger and bigger to infinity. The domain in this case, all the x values except for where there's an asymptote. So you can either write it negative infinity less than x less than negative 3 where the vertical asymptote is, and negative 3 less than x less than infinity, or you can write all real numbers x cannot equal negative 3. Range. Let's erase this. Range is talking lowest y value, so I look at the bottom of the graph, and I look at the lowest possible y value. So this part of the graph is going down. So as I'm reading it, it's coming up to somewhere. The curve on a rational function, there's always a horizontal asymptote. So it's curving to this asymptote right here. So that's the line, the imaginary line the graph cannot cross. It's at x or y equals 2. So the range is going to be from negative infinity less than y, we're talking range, to negative 2. On the same side we have, or on the other side of the asymptote, there's another portion of the graph. This portion starts just above y equals 2, so it's positive 2, gotta change it. And it goes to positive infinity, so it's positive 2 here, not negative 2. Sorry. Positive 2, and then the other portion of the graph starts at 2, and the y value climbs all the way to infinity. You can also rewrite this as all real numbers except the y cannot equal 2. Zeros, whereas across the x-axis, looks like here at negative 3.5. X-intercept, that's an actual coordinate, negative 3.50. The y-intercept, whereas across the y-axis, 2.3, 2.5, somewhere in there. 2.25 is what we studied in class. So we do that as a coordinate. The domain restrictions. Now, domain, all real numbers except for this asymptote here. So the domain restriction is at, and we actually have it here too, at negative 3. So domain restriction, x cannot equal negative 3. End behavior, write this just like all the others. As x approaches negative infinity, the y value approaches 1. And let's see here. As x approaches negative infinity, whereas the y value approaching, the graph is topping out, and it's going to top out right at this asymptote at 2. In this case, it's 2. As x goes to positive infinity, the y value goes to, as x goes to positive infinity, as x goes to the right forever and ever and ever, where's the y going? It is getting closer and closer to the asymptote, which is at 2. Just so happens both of them are the same.